Continuing from the previous session of quadrilaterals, this is fourth session. Now, in the previous session, third one, we saw the relationship between different type of parallelograms. Different type of parallelogram means parallelogram, rectangle, rhombus and square. Because every rectangle, rhombus and a square is actually a parallelogram. Now in session 4, we will continue with trapezium and kite. Now, what is a trapezium? A quadrilateral with only one pair of parallel sides is a trapezium. That's it. Means these two sides are parallel. Now just match it like this and like this. No other criteria. Just A, B, C, D, where AD is parallel to BC. Such quadrilaterals are known as trapezium. Now, if AB is equal to CD, then it is known as isosceles trapezium. If these two are equal, then. So, if in that case, the figure will modify a little bit.
That doesn't mean it's parallel.
No. In case of a trapezium, only one side is parallel, not both the sides. If both the sides are parallel, it will become a parallelogram.
Okay.
So a quadrilateral has two pair of sides. One pair of opposite sides parallel, it's a trapezium. Both pair parallel, then it is a parallelogram. So if these two are equal, in that case, the diagonals will be also equal. If these two are equal, then the diagonals will be also equal. But they won't bisect, they will only intersect. Intersect means just crossing each other. Bisecting means intersecting at equal intervals, means this part equal to this part. So this does not happen. This happens in case of parallelogram. So in isosceles trapezium, these two diagonals are equal and opposite sides are these two, one pair of sides parallel and the other two sides are equal. This one is trapezium. What is the area of a trapezium? Can you answer? The area of trapezium? Area of trapezium is the height. Now, before area of trapezium, what is the area of a parallelogram? If we go with the area of all the figures that we have seen so far, the first one is a parallelogram. What is the area of parallelogram? Half into base into height. Where this is the base and this is the height. Now, is this half correct?
Yes.
Sure?
No.
No. Half into base into height is area for any triangle, not for a parallelogram. And parallelogram is nothing but two triangles. So just remove this half. It is base into height. Area of parallelogram is simply the base multiplied by height. What is the area for rectangle?
Base into height.
Same, base into height, or we reduce down to length into breadth, where in case of a rectangle, this is length and this is breadth. So L into B, length into breadth. Area of a square?
S into L.
A into A, means where L and B both are same. So it is considered as A or a side S. So you can write S square or A square. Now, what about the area of a rhombus?
It's D1 into D2.
What about the area of a rhombus?
Diagonal into diagonal.
Area of rhombus is again B into H, because the parallelograms we can calculate. But there is one more method. Why? In case of a rhombus, diagonals bisect each other at 90 degree. So if we consider this triangle, area will be half into base into height. And here again half into base into height. So these two heights will add to another diagonal. As a result, half and this common diagonal is half and this diagonal is common. So half into product of diagonals. This will be the area for which one? A rhombus. Okay. Now, continuing this, what will the area of trapezium? Area of trapezium is half into base into sum of parallel sides. Means AD plus BC by 2, no, not base, height. Half into height into sum of parallel sides. So the sum parallel sides BC and AD, add these two, divide by 2. So we are finding somewhere the mid between. So this value multiplied by height. If let's say this is the height of this isosceles trapezium is h, and these two values, let's say this is A and this is B. So this will reduce down to half into h into A plus B. So this is the area of a isosceles trapezium. Now the last one in the sequence is a kite. What is a kite? Kite is a quadrilateral where let's consider this A, B, C and D is a kite where these two adjacent sides are equal and these two adjacent sides are equal, and the diagonal intersect, not bisect, intersect each other at 90 degree, whereas these two parts of diagonals are equal but not these two. OA is equal to OC, but OD is not equal to OB. Okay, opposite sides, these two sides are the opposite angles, these two angles are equal but not these two angles are equal. This is a kite. In case of kite also, what will be the area? Simply because these two diagonals are intersecting at 90 degree, so we can find the area of this triangle and this triangle and we can add it. In case of here, if we have to find the area of angle ACD is half into OD into AC, and ABC, area for triangle ABC is half, put the area symbol, half into OB into AC. So area of kite or ABCD will be half into AC common into OB plus OD, because this kite is summation of these two. So OB plus OD will become BG. Simply it is half into AC into BD. So similar to the formula of rhombus, where the area of rhombus and area of kite both is half into product of diagonals.